Hello everyone, calculations time, Dr. Dave. This is a session on ideal body weight and adjusted ideal body weight. And we learned about the BMI, but there are people that have, if you have a large accumulation of adipose tissue, so a lot of fat that's around the small proportion of water compared to muscle tissue, can lead to changes in dosing when a person has a really high BMI. And what this is being used for is to correct some of that. So you can read what's here, but I just want to go over the parts that are about the math for the meantime. So an ideal body weight for an adult that's 5 feet and taller, so as long as the person is over 5 feet or they are 5 feet, you use the following calculations. Notice the difference here is that there is one for men and there is one for women. The ideal body weight is in kilograms, is what it comes out to be. And the difference is that you will have a different number that you're adding in the beginning. So you need the number of inches that are over 4 feet. You multiply that by 2.3 and you add either 50 for men or 45.5 for females. All right. Then once it's calculated, you could compare it to their actual weight and see if they're underweight, overweight, or obese. And again, you can read what is written there. I don't want to waste the video time on that. I'd rather do the math portion of it. If somebody is really obese, you can do an adjusted body weight. So you take the adjusted body weight is going to be the ideal body weight, right? You're going to be multiplying 0.4 times their actual body weight minus their ideal body weight. So the difference between what you calculated for ideal body weight right here, subtracted from their actual body weight, and you multiply that by 0.4. Why the 0.4? As you can see, 40% of the extra weight is lean body mass, while a hydrophilic drug will distribute into that. Right? So the extra weight is mostly fat, but 40% of that is going to be mass, where a drug, most likely for a drug, is going to be distributed into. Hydrophilic drugs are water-soluble drugs. They like water. They don't like fat. They're not going to distribute into fat tissue as much. And you can see that we use it in dosing. So let's look at the calculations. That's what we're interested here in this session. If you want to calculate the ideal body weight, 87-year-old female, 5 feet, 1 inch tall, weighs 111 pounds. It's a female. We need to look at a female. The female is going to be 45.5 kgs, and then we're going to take 2.3 times the number of inches that they are over 5 feet. So in our case, we have, let's go back here to our female, our 87-year-old female. So we determined that she was a female. Then we have to determine the number of feet over 5 inches. So she she is 1 inch over 5 inches. So the ideal body weight is going to be equal to 45.5. This is from the equation, right? kg plus 2.3 times the inches that she's over 5 feet, which is 1, gives us a 47.8 kg. So her ideal body weight is 47.8 kilograms. All right. All right. So we can also convert her pounds and see how much she's actually over or under, what the difference would be. So calculate the adjusted body weight for 50-year-old female. Now this person is 5 feet 11 inches tall and they weigh 288 pounds. So we know it's a female. Oh, sorry. We know it's a male. Apologize. So this is a male. So we have a different calculation. But the second thing we do is we do the feet over 5 inches. This person is the number of inches over 5 feet. This person is 11 inches over 5 feet. So our calculation for ideal body weight, which is where we're going to start, is 50, given from the equation, plus 2.3 times the number of inches over 5 feet. They are 11 inches over 5 feet. This is going to give us 75.3 kg. In our equation that's given to us for adjusted, we now can do an adjusted by taking the ideal body weight plus the difference between the actual and ideal times that 40%. All right. So the adjusted ideal body weight is going to be the ideal body weight, 75.3, right? Then it's going to be plus 0.4, 40% times the difference between the actual minus the ideal. So the actual is going to be 288 divided by 2.2. Let me try that again. 188, 288 divided by 2.2 is 130.91, we'll say. 130.91. What did I do? I converted pounds into kilograms. 130.91. And I'm sure you know how to do that right now. And this is the difference between the actual and the calculated ideal. If we do that in the calculator, we should get about 97.54 kgs as the adjusted body weight, taking into consideration the more over the ideal plus the proportion of adipose tissue being in there. All right. So again, you don't have to memorize these formulas for adjusted or for ideal. Just have to be able to utilize them in the form of a question. All right. Questions that you will see in your examinations as well as in real life, because pharmacy calculations is important because it's the only subject matter that counts.